So when I ask you to rewrite it, remember that this number here is the root. So it's saying square root of 4, and then this is your power. So there's the rewritten part. And then when you go to evaluate it, you can type it in the calculator this way, or you can type it in this way, or you can do it by yourself, either way, and you'll get 32. Okay, this one again is my root, so it's going to be cube root. Make sure the 3 is inside that little crevice there, and it's 343 to the negative 1. That's the rewritten. Now if we do it ourselves, the cube root of 343 is 7, but then to get rid of this negative x1, we put it underneath in a fraction form. No decimals. Remember, if your calculator gives you a decimal, to transform it into a fraction. So cube root of 40 cannot be done. It's a decimal, and this says no decimals. So we need to think of our list of perfect cubes. And to get a list of perfect cubes, you would cube a bunch of numbers. So like 1 cubed is 1, and 2 cubed is 8. You can use your calculator. 3 cubed, 4 cubed, 5 cubed, etc. So now we're going to, on a calculator, go ahead and do 40 divided by one of these numbers right here, and see which number can be divided evenly. So we can do 40 divided by 8, which means we're going to do the cube root of 8 times the cube root of 5, because 8 times 5 is 40. Cube root of 8 is a perfect cube. That will give me 2. This one can't be done. It would turn it into a decimal, so we're just going to write it next to it. So times cube root of 5. Same idea, but we need a list of perfect fourths. So 1 to the 4th is 1, and 2 to the 4th is 16, and 3 to the 4th is 81. 4 to the 4th is 256. So we're looking for what number we can divide 324 by, something right here, one of these numbers, and it'll come out evenly. So it's going to be the 4th root of 81 times the 4th root of 4. So the 4th root of 81 is a perfect 4th power. It's just plain 3. 4th root of 4 is just exactly that, 4th root of 4. Now notice that these are all underneath the cube root, so we are going to split them. So we're going to go ahead and do the cube root of 8, cube root of x cubed, cube root of y to the 6th, and cube root of z to the 3rd. That's 2. Now this can be rewritten. Rewrite them anytime you want. 3 over 3. Y is 6 over 3, and the z is 3 over 3. Now 2 is going to be there. Now if you notice that this can be reduced just to x to the 1. You don't have to write the 1 if you don't want to. 6 divided by 3 is 2, and the z to the 1. And so if you notice all three of these up here, we started with one big root and we split them. We can what we call unsplit them by bringing them back together. So it's the 4th root of, and let's just do 96 divided by 6. So if we do 96 divided by 6, we'll get 16, and then this is a perfect 4th power, so or root, so if you type it in your calculator or you just know them by now, the answer will be 2. Now whenever we add or subtract radicals, we need to have like terms. So these have to be the same. So if they're not the same, we need to reduce them. And so if I say the word reduce, that means it gets it smaller. 3 can't be put any smaller, so we need to reduce this. So it's 4 and 3. That 5 carries on. Notice that that 5 is being multiplied. So the square root of 4 is 2. And then we're going to get 10 square root of 3 minus 12 square root of 3. So then we do 10 take away 12, which is negative 2 square root of 3. This is saying take your f and subtract your g. Well, your f is 5x squared plus 3 minus your g, since it's more than one term, we need to put parentheses around it. We're going to change the minus to plus the opposite, which means the opposite sign has to go to everything inside. And now we just add our like terms up. And this 3 and this minus 3 will cancel. This is one of those compositions. It's one thing is inside of the other. So let's start by bringing this g down. So the g is 2x plus 3. And we're going to lightly cross that off and put a parenthesis in its spot. And we're going to put the f problem inside that parenthesis. And now it's just a normal problem, so we're going to distribute. And then that will give us 10x squared plus 9. Again, it's multiplication. So we're going to take the F problem and times it by the G problem. Okay, first of all, 8 times 2. That's 16. Now we have x to the 2/3 times x to the 3/5. And this goes back, even though we talked about this in lesson 5.5, it goes back to your 5.2 exponent rules. You need to know when to add these and when to subtract them. Don't think that during the test you can come up to me and say, do I add them? Do I multiply them? Because I won't answer that. That's something you already need to know. So we're going to add these when they're written side by side, one at a time. We keep the base, but now we need to add those. So to add those, we are going to get a common denominator. So 3 times what is 15? We're going to multiply that top by 5, and we're going to get 10. And if you think about it, 10/15 is 2/3. Okay, 5 times what is 15? So we're going to multiply that by 3 and get 9. So now we're going to go 10/15 plus 9/15, and that will give us 19/15. And so that is our new exponent. It's a division problem, so set it up first. Your F being divided by your G. So again, 8 divided by 2 is 4. And the rule here is to subtract. So 2/3 take away 3/5. It's the same fraction, so it's going to be the same denominators. I'll just recopy what we already had. So 10/15 minus 9/15 will be 1/15. So that is our new exponent. Inverse, now this is lesson 5.6. Inverse, we flip around the x and y, so just switch them. Don't change them. Just reverse the process. However, in this one, we want the inverse equation, so we're going to flip-flop the letters. Remember I said sometimes it would be helpful if you rewrote it this way. And now we're going to solve for y, so we're going to keep this here. We're going to minus 2. And then most of you are going to divide by 1/2, which is fine, because that's the way your Algebra 1 teacher taught it. But this is not reduced. Do not give me this. This would not be the final answer. So there's a 1 right out front here, so we need to do 1x divided by 1/2. So 1 divided by 1/2 is actually 2, because remember we multiply by the reciprocal. And then over here it's -2 divided by 1/2, which is the same as -2 times the reciprocal, which will be -4. Are these inverses of each other? Remember I said I don't necessarily do it the way the book recommends it, just because I find it easier to just find the inverse. So if you take one of them, it doesn't matter which one. Let's say we start with the first one here. And we actually go through and let's find the inverse. So we're going to multiply both sides by 3 to get rid of dividing, which is the same as y plus 2 equals 3x right now, right? We're going to start solving for y. So we're going to subtract 2 and subtract 2. So I get y is equal to 3x minus 2. So we started with the first one and we did all this work and we got this answer. Now see if it matches the function we didn't use. And it does. So yes, they are inverses. So this is a combination of several lessons when we solve. So we want to get the radical alone, so leave this alone. And just ask yourself, how do we get rid of this square root? We're going to square both sides. Now we just solve it like a normal problem. So we're going to subtract 4, divide by 2, and divide by 2. This one we're going to keep this by itself. Minus 3, minus 3. We need to get rid of that 2 first. Remember, we've got to leave this alone. So we're going to divide by 2, divide by 2. So here's the problem. I'm going to write this 2 ways because you can do it one of 2 ways. So we talked in the notes what to do in the case of an exponent that's in fraction form. We said raise both sides to the reciprocal power. And if we raise both sides to reciprocal power, u should get 1/4. But a lot of people struggle with that. They just don't remember it. So what you might want to do is rewrite it. So this here is a root. So that means the square root of x is 1/2. And how do you get rid of a square root? We square both sides. And you still will get the same answer. So in this one, we are going to right away get rid of the square root by squaring. But in order to do this part correctly, you have to remember that it's a subtraction sign, which means I got to do them side by side. So we're going to distribute. Distribute. And that's going to give us x squared minus 8x plus 16. Now this 2 here means it's a quadratic, so we need everything on one side. So we're going to subtract 10, and we're going to add 3x. So we get 0 is equal to x squared minus 5x plus 6. So now we want to factor. So what numbers will multiply to give you 6 and add up to -5? So -2 and -3 will. And I'm just going to carry this up here. But those are not our answers. Those are our factors. So remember what we do is we set each factor equal to 0. We did a lot of this last trimester. So then we're going to add 2 and add 2. Add 3 and add 3. And the last solving one is this. Remember, if you read closely, it says D is the distance and H is the height. So when I write my problem out here, again, it may make more sense to you. Remember, this is a root, so just rewrite the problem based on the way that we are used to seeing them. It says determine the eye level height of a person if he or she can see 2.7 miles out. So they are showing you in here that that is the distance. Alright, so to start solving, we are going to square both sides. And when you square this, don't round it on your calculator. We don't round until the very end of the problem. And then we're going to divide by 1.35 to get H all by itself. So H is 5.60 miles. If they give you units in the problem, you should give me units.